So we'll continue from where we left off with the keynote. Thanks for staying here. This talk, we will dive a little bit more into the kind of the mind shift. What does it actually mean on the level of programming, just writing everyday applications, and how we think about design. So hopefully this will further kind of enlighten things. Well, first of all, a couple of words about me. I'm a Spring Framework committer. I focus on Spring MVC and WebSocket. I've been involved with the reactive effort for Spring 5. So there's a long-running shift to concurrency that we've had in our industry, where we have been doing things in a certain way for a long time, and we've tried to move towards different models in the past with SOA and to make things more distributed. But for a long time, kind of the simplest thing that makes sense is what worked, and that was the conventional wisdom that we had for a very long time. But things have been coming along all this time. If you think about where we come from, well, it wasn't so long ago where the deployment target for us was the application server. That is the place where we ran things, and for sure that still is the place for many, but it isn't the only place, and maybe we can begin to see that that isn't going to be the place always. The things are changing. And the conventional wisdom again was keep it simple, don't distribute if you don't have to, and we wrote applications that were relatively self-sufficient, relatively speaking, didn't really do a lot of things reaching out to other services, to other applications. Maybe you did a remote call to a database, things like that. And we used imperative programming, which is really the simplest way to write logic. Now, where we're going is that these are the things that maybe aren't there for every application, but these are the things that are quite common. This isn't anymore some sort of isolated or hyped up situation. Now, cloud deployment is very likely where we might be running. We have distributed applications that are being designed as interdependent services, and we're looking to achieve internet kind of scale and resilience, and latency is becoming very much the norm and not the exception. So what's the impact on programming model? Well, the key advantage of imperative was that it's very simple, the way you lay out the logic. If there's an exception that rises, you just catch it, and you're in a single call stack scenario, and you deal with that, and you continue with your logic. And that's the easiest way to write things. But the more we reach out to other services, we're doing asynchronous I/O, then we're dealing with asynchronicity anyway. We're starting to introduce callbacks, we're starting to deal with thread pools, and when you have this popping up all over the place, pretty soon it becomes very difficult to manage and very difficult to deal with, and we fundamentally don't have the right tools. We're not dealing with we're gradually stepping into a territory where we just don't have the right tools. There is no black and white line, but at some point that happens. And there's a certain cost associated that we know and we kind of ignore because it takes quite a bit of effort to kind of switch to a different approach. But at some point we have to accept that we are in a different territory and begin to look for different solutions. So really what we need is an asynchronous foundation. We need to use asynchronous APIs. We need to stick within few threads and then make efficient use of the resources. And that is a major shift for the way we write and create applications. There's no other way to put it. But on the other side of the scale, there are major benefits too, and that's really what we're looking to achieve. Fundamentally deal with asynchronicity, not as something that happens to us and we must deal with, but something that we actually are approaching with the right tools. And of course, the natural first question might be, well, how can I become asynchronous? How can I be like Node if I don't have non-blocking libraries in the first place? Well, there are some, as we pointed out in the keynote already, and there are various ways and approaches appearing. It is a very gradual process, but it isn't a situation where you'll have to wait until all of that appears. Fortunately, in the reactive programming and reactive libraries, APIs, there are ways that you can introduce still latency kind of blocking, essentially blocking operations, and put them on a thread pool, but at least you begin to isolate those places and you're adopting a different approach. You really start to change the way you think about application design, and hopefully these places are going to become fewer and fewer over time. So we've made different attempts to explain this in the past, but one of the really most effective ways that I found is to talk about the process of creating a Java asynchronous API. How would we go about doing that? So let's imagine that we have a user repository, and the kinds of methods that we can find there are things like this, where you find a user object, you're passing an ID, and then if something goes wrong, you could get an exception. And the way you use that is you put it in a TryCatch block at some point, and then if there's an exception, you do something. If the result comes back, you do something else. This is what we mean by imperative logic. At the cost of blocking and waiting, this may be very fast, or it may take a few seconds. And of course, there's a cost associated with that. But it is the simplest way to write the logic. So now, how do we make that asynchronous? Well, let's replace the return value with the future. Now, we have to remove the exception from that, because the exception may occur in the same thread, or it may occur in a different thread. More likely, it may occur in a different thread. When we're getting back the result, that may be an exception. We have asynchronicity going on. The actual work may be performed on a different thread, so we're no longer making the same single call stack assumption, so we have to remove that from there. And we have to get it from the future instead. And of course, we have to deal with a future with these exceptions that may occur. And really the biggest issue is that when you're dealing with the future, is that at some point you have to get the result from the future, and at that point you're blocking. So now if you have several of these and you're trying to get the results at some point and they depend on each other, you end up back in a blocking situation very quickly, because you can't really work out if you have to do A, B, and C, and A and B have to be done before C, how do we actually do that? You have to wait until A, B, and done, and there isn't a good way to express that without blocking. So it just gets you in a mess very quickly. Now, what about completable feature? In Java 1.8, and Spring 5 will be based on Java 1.8, we have feature with actions, which means that you can attach triggers, things that happen after the feature is completed, and that's essentially a callback mechanism. So we can say, all right, we'll replace the feature with a completable feature, and this allows me to get an asynchronous callback. So I can say something like feature, when complete, give me a user and an exception, whichever, one of them may be null, so we have to check. But you can see here we have a lambda expression that makes the callback a little bit easier to look at. The syntax is actually not so noisy, so that's good. And we do have to check for a null there, see if we got a user or if you got an exception. So that's kind of the mindset that we're in here. Now, what about if we're returning a list of users, if we're returning more than one item? So now our first attempt to do that might be to put a completable feature around it. So we're going to say completable feature with a list of users. Now, the challenge with that is, first of all, that this is very collection kind of oriented, very collection based, because it means that you're not going to get any of these items until they actually become available. It's all or nothing. Now, you may be thinking, why is that a problem? If you're getting users from the database, that's maybe not an issue, but you can imagine generally speaking in an asynchronous API that the data that you're getting back is not necessarily available immediately. So if there's any kind of latency involved, we may be interested to get items one at a time, not when all of them become available. So this can become a challenge. Then the other problem is that there may be too many of these. How do you deal with that? Again, a streaming approach would be a much better scenario where you get the data as it becomes available. And then also, we have an API. We can also return void, and that we can replace with a completable future void. And what this allows us to do is to express when that operation is complete, or if there is an error associated. Again, we're not going to do that through a declaration of an exception, because we are now asynchronous, and we just want a single place where we can find out what happened from the operation. Was it successful, or was there an exception? Now, this is all good, but there are some quirks and challenges. And really, if we take a step back, we can think in terms of streams. We can model asynchronous return values as a stream, and that becomes quite elegant. So we're thinking about a stream of 0 to n items, and you get a notification for each one of those items as it becomes available. It may be one, it may be many. And you also can get a notification if there's an exception. You can think of that as another signal, another outcome, another result. And we also have a completion notification, because that's when there are no more items, right? That's, if you think about a list, that's an aggregated result. But if you're getting items one at a time, you need to know when that stream is over. And if we translate that back into all the various calls that we have, then if you look at the return types all the way on the left, we have void, return value of user, or return value of list of user. And then you have different scenarios there. You may be successful, or you may fail. You may have 0 matches, or you have multiple matches in the case of list of users. And you can see the notifications on the right-hand side that we can model all of that, and it becomes a pretty uniform way of looking and dealing with this. You get 0 or more notifications for data items. You get an error notification in case of a problem, or you get a completion notification when there's no more items. And that becomes kind of a unified way of thinking about dealing with asynchronous results and asynchronous scenarios. So the advantage of doing things in this way, or thinking this way, is that we can represent this with a stream abstraction. And when we do that, we get new possibilities and new opportunities, because we can think about sequences and streams, and we can think about combining them, we can think about transforming them, reducing them, etc. We can have a much nicer functional API where we focus on what we're doing, not how exactly it's being done. Of course, we have the stream API in JDK 1.8. And that is exactly what we're talking about here. We're talking about this kind of functional style API that allows us to work with sequences. But of course, as I mentioned earlier, the stream API is really built for arrays and collections. It's not really, it's pull-based, so it doesn't really fit into situations where the data is coming at its own pace, on its own will, as opposed to being gathered or collected in a collection. So it's really not for latency-sensitive scenarios, and that's where we talk about reactive libraries. They give us a Java 8 Stream-like API. They're push-based, which means that the publisher decides when there's data to be pushed, as opposed to a collection scenario where you can start pulling and you know the data is available. If you rely on a pull-based model and you say, give me the next item, well, if the next item is not there, you're stuck to wait, and that there's blocking involved in that. So that's why we need push-based and not pull-based. And that's perfectly suited for latency sensitive, also for infinite sequences. It doesn't matter how many of these items are going to come, we can still deal with that. Project Reactor is a non-blocking reactive streams foundation for the JVM. In many ways, this is the leading library for reactive streams on the JVM today. Version 2.5 is in milestone phases at the moment, but it's rapidly evolving, and it's already in a pretty advanced place. It is inspired, as we say, by reactive extensions. And reactive extensions, of course, is the set of RX projects like RxJava, RxJS, and many others, starting with RxNet, .NET. So this comes from the side of Microsoft. And the reason why I mention this is because there are lots of good things about reactive extensions. It has an API that gives us all kinds of operators that are supposed to be pretty complete, based on which we can create all kinds of applications in dealing with data sequences. But ultimately, that has different origins than reactive streams. So reactive streams was created separately, industry collaboration. And RxJava was involved in the process of creating our reactive streams, but at the moment, RxJava 1 has a bridge to reactive streams. It's not natively built on reactive streams. And there are discussions to move RxJava to be natively built on reactive streams in version 2. But that philosophical rooting in reactive extensions is actually causing some subtle design questions and issues that they're going to have to resolve. With Reactor, it's actually the other way around. It's philosophically rooted in reactive streams first, but it's also inspired by reactive extensions in terms of the API. So if you have any background with RxJava, if you're used to all the operators, as you move to Reactor, you will find that a lot of these things are there as well, and it will be a very kind of consistent experience. It's also very easy to convert to and from Java 8 APIs. So we'll show that in a moment. But this is Flux. Again, this is the representation for a stream. This is the equivalent of a Java 8 stream. And you can apply various kinds of operators to those data sequences. Mono models a sequence of 1. And it sounds like a useful thing at first. It may not be obvious why it's important to have a Flux versus Mono, but at least for clarity in APIs, where we return a single user or a list of users, it's important to be able to represent that in APIs, because then frameworks and all kinds of tools can reason based on that what they should do differently. So we found pretty early on that it's important to have Flux and Mono, and this is why we have them both in Reactor. And this is how you convert. I just wanted to give a sense for going back and forth between Java 8 stream and Reactor Flux. You can see that there are methods on Flux, so you can create a Flux from a Java 8 stream. Then you can apply a timeout operation. So timeout is, again, something latency related, which is not really a feature of Java 8 streams. And then we can convert back to a stream into a Java 8 stream. So it's pretty easy, and it's pretty fluent to go back and forth between one and the other. And for Mono, there's a similar way. So Mono is comparable. We can go from Mono to stream, but here we're showing completable future because it's much more along those lines. Now, beyond the composition API, the nice thing is that Reactor is backpressure ready. It's based on the reactive streams protocol, and the purpose of the protocol is that producers should not overwhelm consumers. This is a key challenge when you start building these kinds of applications. And in addition to backpressure, there are also certain operators that allow you to deal with situations when there is no other choice, and you might have to buffer too many items coming. You might have to, at some point, drop them or window, aggregate them, etc. Reactive Streams was created as a specification, as an industry collaboration. It's an interesting story in itself because it happened outside of what we know as the Java standards processes today. It's just a bunch of vendors like Kazing and formerly TypeSafe, Pivotal, Netflix, and others. They came together and they created a specification which was found to be very, very useful by the JDK team, so they decided to include it in Java 9. So actually Java 9 is going to have the interfaces from Reactive Streams adopted in a class called Flow. And really the purpose of Reactive Streams is to be a specification for interoperability among components. So if you have a RxJava reactive library, if you have Akka Streams, if you have Reactor, these are different kinds of components, and you can imagine that as you begin to see an ecosystem of libraries, like I mentioned, MongoDB and Couchbase and others, and Spring Web Reactive, and all the way down to the runtime with Tomcat and Jetty and Netty. You have reactive streams in all these different places. Well, they're all using some kind of implementation internally of their asynchronicity, and we want to be able to have this kind of end-to-end flow control so that all the way from the Tomcat layer, we can push back and say, this client is not ready to read more data as we're writing out to the response, so we're pushing back, and that can propagate through all those layers back to the source where the data is coming from. That's the idea behind reactive streams, is that we have a mechanism, a kind of protocol for these components to talk to each other to make sure that producers don't overwhelm consumers. So in the Reactive Streams API, we have a publisher. Again, this is Reactive Streams. Looking at the contracts is purely just for kind of getting an understanding. Typically, you won't be working on this level. This is kind of more of a low level where frameworks need to deal. But a publisher is just, simple method where you provide a subscriber. And then the subscriber is the one that receives all the data. In terms of difficulty, publisher is where all the challenges are. To create a publisher is really not easy because you must do things asynchronously. You have to use various mechanisms. To be a subscriber should be easy, and you're basically receiving the data. You're first subscribing, then you're getting a subscription, and that subscription is your volume control. It allows you to say, I want more items, or I don't want any items, or just cancel, don't give me any more items. And there's also an error notification and on complete. So these are the main things when you talk about streaming. These are the main signals that a subscriber can receive. So again, this is just for your background understanding. The level of reactive streams is really more conceptually of interest. Really, it's not something that you should be doing directly in applications. Now, this is what the repository would look like if we redesigned it using reactor types, like mono and flux. If we find a user, we get back a mono of a user. If we do find all, we get a flux of users. And then for save, you get something like this, mono void, which basically just tells you when the operation is complete. Because remember, this is not blocking now. Simply returning from that method no longer tells you that the operation is done. It just means that you invoked it. So it's kind of a very different way of doing things, where you now have to not wait and then continue, but you have to compose on the return value what should be done next. So if you think of an entire algorithm from top to bottom, where previously you could just write it like that from top to bottom, now you have to split it into chunks, and you have to compose these chunks together and say, first I want to invoke the user repository. When that's done, this is what I want to do. And then I want to combine that with some other result. So again, it's a different way of doing things, but you're at least a level above callbacks, and you're not dealing directly with callbacks, and the syntax allows you to still read the source. Now, what happens, this is an example of using this repository. This may look very similar to using the Java 8 Stream API, where we apply different kinds of operators. We can say, find me all users, and then we're going to do some kind of filtering, so we only get some of them. Then we're going to provide some map-style transformation of the user. In this case, we're turning it into a string, just taking the username. Then we're logging the signals that are going back and forth. And the key thing here to understand when using Flux or Mono is that nothing happens until there is a subscriber. There's no data flowing at all. So unlike imperative programming, where you write your logic and then you can step through with the debugger and it's executing the moment that you write it, with this kind of style logic, you're composing your logic first. So we're passing through once. And only when there's a subscriber at the end does the data actually start flowing. So you can think of it as two phases. Phase one, you're setting up your pipeline. You're defining what will happen. And then step two, the data actually starts flowing through. So in this case, if we removed subscriber, find all doesn't actually do anything until somebody subscribes and we begin to draw data. So what happens when we run this is, you remember this log statement there before the end? That's going to log all the signals that are flowing back and forth. It's kind of a useful tool. The first thing we see is onSubscribe. And that happens when we subscribe. If you remember, the publisher contract has an unsubscribe method. Then the subscriber is requesting items, and there's a shortcut if you want all the data, if you don't want to consume one at a time or things like that. Then you can just give long max value, and that is the signal for give me everything you've got. And in this case, we have one or more users, and then eventually we get a completion notification, and that's the end of that. Now, we can also do things like this. We can introduce an operator that says, give me 2 at a time. And what that means is that automatically under the covers, and again, this is, you're not dealing directly with reactive streams, you're using operators and the Reactor library to do things like that for you. It's actually requesting 2 items, and then the producer gives you 2 items, and then it doesn't give you any more, because if you're doing something with these items, and that takes a little bit longer, producer is not going to give you more until you say, give me 2 more. So now we're consuming 2 items at a time. So any questions, by the way? Okay, so what does this mean on the side of Spring? Well, in Spring 5, again, we're going to provide support for reactive programming models. We're going to make this a first-class citizen. We have a reactive Spring Web effort. It really makes sense to start at the web layer because that's where applications start, and we're using Reactive Core as a dependency. So these are examples of controller methods. Now we're taking that user repository, finding the data, and we're exposing that through the web. And when we give a flux of users back to Spring MVC or the web layer, Spring Web Reactive, it now needs to take that flux and connect it with the runtime underneath. And do everything that's necessary with reactive back pressure. Which means that, again, if we have a slow consumer, a slow client over Wi-Fi, then if they're not able to consume immediately, that's going to apply back pressure back to the repository. So that's what we're setting up here. And all of this is supported in the Spring MVC, Spring Web Reactive already. We have also done a lot of work on the level of codecs and HTTP message conversion that you may know with Jackson and with XML conversion. And we've had some interesting questions that we had to address there because, I mean, a lot of these libraries, they're still blocking. They don't have alternatives yet. So, for example, with Jackson, what we do is we actually serialize one user at a time, and then we create an array, and we stream that back out so that it isn't blocking. Obviously, if we try to give the whole thing to Jackson, we don't really want to do that. We want to do it one item at a time. So we've gone through a lot of questions like that to make sure that, on the surface, this looks like any other controller method, but what goes on underneath is completely different. And you can see also that we have first-class support. There's no reason. It's quite natural to support other reactive libraries. So if you happen to use RxJava in your application, then you can design everything using observable and then return that observable from your controller. And underneath, what we do is, because we use Reactor for our own processing, we naturally convert, and reactive streams is the basis for that, and then we deal with the flux internally. So we have a reactive web engine, essentially, where all of our internal framework contracts have been rewritten to be asynchronous and non-blocking. We have an HTTP reactive streams layer that we've built on top of Servlet 3.1, Netty, and Undertow. And there is a Spring Reactive project, as I mentioned earlier, that we're going to merge soon. We've started to create some of the tickets in Spring's Jira, so you will see some description of the reactive work that we plan to have. Just generally, the idea for the first milestone in a couple of months, I mean, obviously, we're replicating all of what Spring MVC has. But for the first milestone, we're focusing on REST scenarios. So the idea is that when the first milestone is ready, you'll be able to take a REST controller, and then try things out in this reactive web engine. We do plan to have, and we already have HTML rendering. We have FreeMarker, and TimeLeaf is also being worked on together with the TimeLeaf team. So we do want to have the ability to alternate between kind of response body style and view resolution HTML rendering, but we're not going to have initially very advanced support for HTML with forms and data binding, etc. All of that is going to come in subsequent milestones. So we have to somehow divide the problem because we can't deliver all of that in first milestone. Obviously, it's a huge amount of effort and work, but we have a strategy that we're executing on. We have a direction, so it's just a matter of putting these things together. And for the first milestone, it's going to be a focus on REST scenarios. So I think we're probably a little bit early, but are there any questions anybody wants to ask? Let's see, back there.
How to test this new programming model? Is there also support for all these layers, for the repository, for the web layer?
Yeah, so I mean, a lot of what we do in testing isn't going to change necessarily. Many of the things that we do are still going to be there. Kind of the more challenging things is that you're dealing with an asynchronous API. How do you verify the values? So there are different techniques there, and if you look at the Spring Reactive repository, we already have a lot of examples of what we do for our own testing. Again, creating a web framework is quite a bit like creating an application, so a lot of what we do, a lot of the things we go through are the things that applications are going to go through. We already have, in Reactor in particular, we have kind of a test subscriber, which gives you all kinds of methods to assert what's in a flux, how many items, and then you can say, get me the next 5, and then tell me what they are, let me assert them. So there are things like that that's already available. But again, for the most part, it's very similar to what we do today.
Okay.
I saw another one back then. Yes, another hand.
What about Spring Boot and Netty? Will there be support?
Yes, there will be support in Spring Boot and Netty, for Netty in particular. Obviously, what we do in the Spring Framework now, as you can see, we already have integration tests with Netty, Tomcat, Jetty, and Undertow. And we plan to support all of that with Boot. There's actually work underway at the moment to create a bootstrap mechanism which is going to accommodate all of these different possible runtime choices. Where previously kind of a servlet API was a certain automatic default that gives you certain assumptions. Now we have to separate that assumption as well at the boot layer, and that's something that's being actually actively worked on at the moment.
One more?
Yeah.
What about WebSockets?
What about WebSockets? Yes, good question. So WebSockets are actually quite, you could say asynchronous by nature, but as you know, in the Spring Framework, we have extensive support for STOMP messaging on WebSockets, Spring messaging, and we're working on kind of a solution there that combines reactive streams and Spring messaging in a way that Spring messaging and Spring integration has always been quite asynchronous in nature with message channels and message passing. So there's a lot of overlap with reactive streams, in fact. But what reactive streams brings is the concept of back pressure. And so we're trying to merge those two concepts. We have some prototypes. It's still relatively early, but two things you'll see. Number one, there's going to be a reactive streams-based API to use WebSockets. First of all, translating whatever the WebSocket API is, whether it's JSR-356 or Netty, to reactive stream semantics so you can consume WebSocket messages with back pressure. And then on top of that, there's going to be some way that reactive streams and Spring messaging are going to, and I don't know what the word is yet, but something. Yes, I saw more hands up here. All right, well, we're back there, sure.
Hi.
Hi.
If we have a complete product with the front-end app, single app, and then the back-end, how would you suggest that we do streaming of these results? For example, at transport layer, what we use on the front-end to get the streaming, all the all the flow.
So is the question, how does this apply across network boundaries?
Yes.
Okay.
Yes.
Yes, so reactive streams primarily deals with what happens within a JVM with all the components. There are some efforts like reactive socket for translating that across network boundaries. Basically the same idea with backpressure over different transports, whether it's WebSocket, HTTP2, HTTP1 as well. But outside of that, Stefan spoke about this earlier in the keynote. There is a kind of a natural form of backpressure mechanism that occurs when you're talking across network boundaries, because as long as within the JVM you have an ability to push back to the source, then eventually your network buffers fill up, and that naturally slows down, and as long as that can translate into backpressure back to the source, things tend to work out. But obviously, it would be better to rely on an explicit mechanism. So at the moment, it's in that level, basically. There isn't anything more than that, but there are initiatives, and I think it's important to start in the JVM because that's where we really need to deal efficiently with resources. And then across network boundaries, we will see more solutions eventually. Now, on the client side, you do have things like RxJS, and there's actually now a Reactor Core JavaScript module as well that's being created. So you will be able to use many of the same mechanisms which make just as much sense in other languages, and especially in the browser, you know, and JavaScript.
Thank you.
Mm-hmm. Maybe over here, we can move over here a little bit. One on the way there, right by you. Oh.
How do you deal with ThreadLocal variables?
Oh, could you hold that question? There is no good answer at the moment. I mean, this is one of those questions which, you know, we still haven't gotten to an answer. What exactly we do with that? Whether we do some kind of thread affinity and we try to, you know, I mean, there's no denying that we were changing threads, and now we have to somehow translate what used to be a convenience into this new world. We don't know yet what the answer is, but we're going to have to find something.
Well, my question was slightly less general than that, but how are you going to deal with request scope in the reactive?
Oh, you're going to rub it in. Okay. Well, even more emphatic. I don't have an answer. No, this is specifically something that we're looking at, and we're trying to figure out. In fact, probably right after the first milestone, it isn't, you know, the concept of locale, for example, is where this might come in. Also for HTML rendering, you know, that's useful, so the view layer can access information about the request, but it isn't one of those first priorities, so we're probably not going to tackle that for M1, but shortly after that. And now that you're asking questions, it's going to make us think even more about it. Yes?
Hi, probably that's also related to the question what was asked related to ThreadLocal. How will it all work with transactions when you like mark some code block as transactional and then you just return a flux of data? How it will work?
Yeah, it's along the same lines. It's actually a really good question. One of the ways in which this may translate may follow the paradigm in which, for example, you deal with thread boundaries today. So there are operators in RxJava, in reactive extensions, and also in Reactor to request a thread boundary when you're publishing items. So if an item is coming downstream, you can say publish on, and then that always uses a particular threading mechanism to switch. There's also a subscribe on mechanism which at boundaries of data signals coming into the publisher switches threads. So it could be that this ends up being expressed through operators where you start a transaction and you end it. How exactly we're going to pull it together, I don't know. But this is exactly what we are here to do. We encounter these issues to which at first there are no answers. When we started a year and a half ago, there were many questions. And as we go through them one by one, every question resolved is one thing less that has to be figured out. You know, as you look out to what's available today, we find that a lot of the solutions aren't answering these questions necessarily. We come from a certain place and a certain background that we know these are questions that we need to address. So, you know, sorry, I don't have a better answer, but these are things we're looking at. All right, well, thanks very much, and enjoy the rest of the conference.